Okay, welcome back. Let's find the integral of the square root of 9 minus x squared, everything divided by x squared. All right? Looking at this, again, remember we are using trigonometric substitutions in this kind of integrals. And what you notice immediately is that there is a constant minus x squared. And when you see this, this calls for substitution of either cosine or sine, because we can use the trig identity, because I'm seeing that, so I can think of the trig identity 1 minus sine squared of x is cos squared of x, or if you like, 1 minus cosine squared of x is also equal to sine squared of x. This is from the Pythagorean identity directly. Okay, so because of that, because I'm seeing 1 minus, a constant minus sine squared or a constant minus cosine squared, when I see that there, I think about making a substitution. So I can say I can substitute x for sine of theta or for cosine of theta. So let's do that. I think I've done this, so it should be easier. So if we let x be sine, it doesn't matter. You could use cosine, it doesn't matter at all. Any of them will work. So if we let x be 3 sine theta, and why am I introducing 3 there? Because when I put x back, I'm going to get, that's x squared there. So when I square it, I'm going to get 9 sine squared of theta. And I'm doing that intentionally so that I have 9 there and 9 here, so that I can factorize the 9 out. Okay? So intentionally, when I make the substitution, I want to introduce 9 into this second term here, so that I can factorize 9 out. And that's the reason why the 3 is appearing there. So if we let x be 3 sine of theta, and then differentiate both sides, what do we have? So dx by d theta is going to be 3 cosine of theta. So dx is therefore 3 cos theta d theta. So there was a dx by d theta here, the d theta goes there directly. It's always important to write in a single step so you don't spend too much time writing this. And so because of that, I'm going to, where there is dx, I will put 3 cos theta d theta, and where there is x, in these two places, I'm going to put 3 sine of theta. If I do that, if we substitute that in, what do we have? So I'm going to have to get rid of this and this. Okay, so the x squared disappears, and I put x squared is now represented by 3 sine theta everything squared, which is 9 sine squared theta. And the same thing is going to go here. All right, so we replace that with 9 sine squared of theta, and dx is now going to be replaced by 3 cos theta d theta, like that. All right, so the 9, there is a 9 there and a 9 here, and there is a square root. So when I factorize it out, I get 9 inside the square root sign. I get 9 into 1 plus sine squared of theta, but then I can remove 9 out and it becomes 3, and that is this 3 here. And then this 3 that came from here, I can also take it out now, so it's going to be this one. And this 9 also goes out, but it is in the denominator, so it's going to be down there. Obviously, this will cancel, but leave it now for now. And now this leaves me with 1 minus sine squared of theta. And we showed there that 1 minus sine squared of theta is cosine squared of theta. So root of cosine squared of theta is just cos theta. So this becomes cosine of theta. Then cosine of theta multiplied by this cosine of theta becomes cosine squared of theta. I hope this is making sense. All right. And the denominator is still sine squared of theta. So obviously that constant out disappears. It's 1. And I'm left with cos squared of theta over sine squared of theta, which you would know is cot squared of theta, but we can rearrange this better. All right, so if we divide this, we get cot squared of theta, the reciprocal of tan, but squared. Cot squared of theta by the Pythagorean identity, when we rearrange it by dividing by cosine, we will get that cot squared of theta is the same as cosec squared of theta minus 1. So I'm saying that cot squared of theta is the same as cosec squared of theta, or in short we write CSC for cosec. So cosec squared of theta minus 1. All right, so cot squared of theta, by trig identities we can show that this is this. So I can therefore rearrange this, remove that and put this in its place. And what do we get? If we do that, we have that. The integral of cosec squared is easier to get. All right, so if you open that bracket or integrate that and integrate the two terms, the integral of cosec squared is found by thinking about the derivative. So if I differentiate cot theta, I get negative cosec squared of theta. So that means that if I integrate cosec squared, I must get cot. But I don't have negative here. So that means if this is negative, then that is positive. But if this is positive, then that must be negative, which is to say that the integral of this is going to be negative cot of theta. Okay? The integral of 1 dx or d theta is just theta. So therefore, my answer for this is negative cot theta plus c. All right? And that becomes the integral, except that I still need to write this in terms of x. So if we're going to do that, there are actually two ways we could do this. I'll try and show both. Okay, and so in order for us to find this, well, x is 3 sine theta, so that means sine of theta is x over 3. And so if I draw that, I draw a right angle triangle and use the definition for sine, opposite over hypotenuse, like that, then opposite is x, and the angle sine of the angle theta there, so the opposite to the angle is x there, and the hypotenuse is going to be 3. And so I can find the adjacent by saying 3 squared minus x squared, the square root. So the square root of hypotenuse squared minus opposite squared will give me the adjacent, all right? So the square root of 9 minus x squared. That is my value of my adjacent. And with that knowledge, I can now find cot, because cot is the reciprocal of tan. Now tan of theta is x over the square root of 9 minus x squared, and that means that cot being the reciprocal must be this divided by that. So if tangent is x over that, then cot must be this divided by that. So I can therefore write that value there becomes negative of this divided by that, okay, for cot of x, like that. So cot of theta is 1 over tan, the reciprocal of tangent. And since tangent is x over the root of 9 minus x squared, cot must be the opposite, which means taking this divided by the opposite, which is what we have there. All right. The next is to find this theta here. Because sine of theta is x over 3, theta must be arc sine, okay, or sine inverse of x divided by 3. All right. Theta is arc sine x over 3, and therefore my integral becomes, reduces to, that should now be easy, because we are simply inserting these values that we found, and we will get negative the square root of 9 minus x squared over x, and then it will be plus arc sine of x over 3 plus c. And this is the integral, this is the result of this integral, okay? Right, see you in the next video. Hope this is making sense. Please like the videos if you like them, and consider subscribing so that when we post new videos you are notified. All right, let's go to the next one.